KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Mass energy relation. So I hope you already know from the Einstein equation E is equal to mc square. Here m is the mass in terms of kilogram. So c is the velocity of light. So the value of velocity of light c is equal to 3 into 10 power of 8 meter per second. So meter per second is the unit of velocity. Here m is the mass. So suppose if you are taking mass as 1 kilogram, so from this equation E is equal to mc square, m is equal to 1 kilogram. So for the value of c is equal to 3 into 10 power of 8 the whole square. So here E is equal to mc square. Instead of mass we can write 1 kilogram. Instead of velocity of light, so 3 into 10 power of 8. So by this formula here we have square. So 3 into 10 power of 8 the whole square, we are getting 9 into 10 power of 16 joule. Suppose if you are taking 1 kilogram of matter, so 1 kilogram is a very small value. If you are taking 1 kilogram matter, it is converted into energy, we are getting the enormous amount. So we are getting, how much we are getting means 9 into 10 power of 16 joule. So 1 kilogram of matter is converted into energy, it is in enormous amount of energy we are getting. So 9 into 10 power of 16 joule. Suppose if you are taking mass 1 gram means, so 1 gram means 10 power of minus 3. Why? Because of in SI unit mass in terms of kilogram. So here we are having the 1 gram. So 1 kilogram is converted into 1 gram means we are getting the 10 power of minus 3. So remaining it. So always mass we are taking in terms of SI unit only. So for mass the SI unit is kilogram. So here we are having the 1 gram. When 1 kilogram mass is converted into 1 gram, we are getting the value of 10 power of minus 3. So into c square 3 into 10 power of 8 the whole square. So that by solving we are getting 9 into 10 power of 13 joule. So when 1 kilogram of matter is converted into energy, we are getting 9 into 10 power of 16 joule. So instead of 1 kilogram, if you are taking 1 gram means when 1 gram of matter is converted into energy, 1 gram of matter is converted into energy, we are getting 9 into 10 power of 13 joule. Either 1 kilogram or 1 gram, either 1 gram or 1 kilogram, it is a very least value. But when we are taking the least value, we are getting the enormous amount of energy by this relation of E is equal to mc square. So this is the main formula which is used in the mass energy relation. So in sometimes we can convert mass into energy, another sometime so energy is converted into mass. So mass is converted into energy means any other form of energy, kinetic energy, potential energy, so whatever it will be. So mass is converted into energy or energy is converted into mass by this relation E is equal to mc square. So then mass of the proton, I hope you already know. From the beginning of the lesson, you know the mass of the proton, mass of the neutron, mass of the electron. So mass of the proton is equal to 1.672 into 10 power of minus 27 kilogram. So mass of the neutron 1.678 into 10 power of minus 27 kilogram. The mass of neutron is which is slightly greater than the mass of the proton. So mass of the neutron which is slightly greater than the mass of the proton. Here 1.672 but here 1.678. So when compared to the mass of the proton, mass of the neutron is high. Suppose if you are writing the mass of the electron 9.11 into 10 power of minus 31 kilogram. Mass of the proton and the mass of the neutron are in terms of 10 power of minus 27, but when we are taking mass of the electron, it should lie in the range of 10 power of minus 31. While doing the calculation, So mass of the proton in terms of minus 27. So 0, putting 0, then 26 0, then after you can write 1.672. So that is impossible to do the calculations, because here we are having the 10 power of minus 27 for electron 10 power of minus 31. While writing in the SI unit, it is very smallest mass. Why? Because here minus 27, here minus 27, here minus 31. So kilogram is the unit of, kilogram is followed by the SI units. The mass of the proton, the mass of the neutron, the mass of the electron are writing in the SI form. It is considered as a very smallest mass. So instead of SI units, we can find the alternating unit. Why? Because while we are writing in the SI units, its value are very small. So that's why we can find the another value, so another term. So instead of SI units, we can write the mass of the proton, mass of the neutron, mass of the electron in terms of atomic mass unit. So first of all, what is the necessary, why we can use atomic mass unit? Why? Because of mass of the proton, mass of the neutron, mass of the electron are in terms of 10 power of minus 27, 10 power of minus 27, 10 power of minus 31. So if you are writing in the SI units, it's a very small value. So by doing the calculation by this value, so SI unit in the value, if you are going to do the calculation, means it is very difficult to do the calculation. So due to the some unavoidable necessary, so we can use atomic mass unit. So atomic mass unit, so here U is nothing but the symbol of atomic mass unit. So first of all, what is meant by atomic mass unit? So atomic mass unit is nothing but 1/12 of the isotope of the carbon atom 6E12. 1/12 of the isotope of the carbon atom, the 6E12. If you are taking the 6E12, its mass is divided by 12. So it's the 1/12th value, which is equal to 1 atomic mass unit. So atomic, first of all, we know clearly what is the necessity of atomic mass unit. So why we go for the atomic mass unit? Because mass of the particles, either proton, neutron, electron, while we are writing in the SI unit, we are getting the smaller value. So when we go for the calculation, it is very difficult. So due to avoid some necessity, due to avoid some situations, we can use the atomic mass unit. The symbol of atomic mass unit is U. So first of all, what is the definitions of atomic mass unit? Atomic mass unit is nothing but 1/12 of the isotope of the carbon atom 6E12. If you are taking the 6E12, its mass is divided into 1/12, 1/12th value of mass of the 6E12. Its value is taken as the atomic mass unit, which is denoted in the symbol of U. So from the experimental observation, the atomic mass, the value of atomic mass unit is 1.66 into 10 power of minus 27 kilogram, or in terms of electron volt means 931 million electron volt, 931 million electron volt. So U is the symbol of atomic mass unit. So by the definition, 1/12 of the isotope of the carbon atom 6E12, which is the exact definition of the atomic mass unit. The value of atomic mass unit is 1.66 into 10 power of minus 27 kilogram. In another value is 931 million electron. Both are equal to the 1 atomic mass unit. Either if you want to writing in the SI units, so kilogram is the SI unit. If you want to write in terms of SI units, the value of 1 atomic mass unit is 1.66 into 10 power of minus 27 kilogram. Suppose if you want to write in terms of electron volt means its value is 931 million electron volt. So there is two uses of atomic mass unit. There is two uses here while we are using the atomic mass unit. The first one of the values, while writing in the SI units, its value going to be difficult. So for avoiding, we can use atomic mass unit. Another one is, the value of atomic mass unit is 1.66 into 10 power of minus 27 kilogram, while we are writing in the electron volt 931. Here we are having the no power. So this is the second use while we are writing in the atomic mass unit. While we are using in the atomic mass unit, the second use is 931 million electron volt. So suppose here the mass of the proton, mass of the neutron, mass of the electron is here in terms of SI units. Suppose if we want to convert in terms of atomic mass unit, because SI units is very difficult because it is a very low value. So due to this, we can convert it into atomic mass unit. So mass of the proton, here we are having in terms of SI units. Here mass of the neutron in terms of SI unit, mass of the electron in terms of SI unit. So in all these values are in terms of SI units. So totally it is converted into atomic mass unit. Here you are having the mass of the proton in terms of atomic mass unit. So, mass of the proton which is equal to, while we are writing in the atomic mass unit, 1.00866 atomic mass unit. So, here mass of the neutron 1.00727 atomic mass unit. Here mass of the electron 0.00055 atomic mass unit. Here we are having the no power. While we are writing in the SI unit, we are having the no power. But while we are writing in the SI units, we have the power. So, this is the major difference between the SI units and the atomic mass units. So, this is the necessity why we go for the atomic mass unit. While we are writing in the SI units, we are having the power 10 power minus 27, 10 power minus 27, 10 power minus 31. But when we are writing in the atomic mass unit, we don't have the power. So, this is the major advantage. This is the major advantage when we can use atomic mass unit instead of SI units. So, here mass of the proton 1.00866 atomic mass unit, mass of the neutron 1.00727 atomic mass unit. So, mass of the electron 0.00055 atomic mass unit. Here mass of the proton and mass of the neutron starts with 1, but the mass of the electron starts with 0. Why? Because of here mass of the electron and mass of the proton in terms of 10 power minus 27. Here mass of the electron in terms of minus 31. So, this is the reason mass of the electron starts with 0. So, mass of the proton, mass of the neutron starts with 1. Why? Because of mass of the proton, mass of the neutron having the power 10 power of minus 27. Also, the value of one atomic mass unit should lie in the range of 10 power of minus 27, 10 power of minus 27, 10 power of minus 27 cancel each other. But if you want to convert mass of the electron in terms of atomic mass unit, then mass of the electron should lie in the range of 10 power of minus 31. Here we are having the 10 power of minus 27. So, this is the reason when the mass of the electron is converted into SI units into atomic mass unit, its value 0.00055 atomic mass unit. So, then we go for the mass defect. So, what is meant by mass defect? So, mass difference is also known as the mass defect. So, mass defect is nothing but mass difference is also known as the mass defect. Suppose consider an atom. So, 8O16. So, 8 oxygen 16. I hope you already know 8 is the atomic number, 16 is the mass number. So, from the atomic number we know how many protons and how many electrons in the nucleus. From mass number we can know how many nucleons in the nucleus. What is meant by the nucleons? So, what is meant by the nucleons? So, mass number indicates number of nucleons in the nucleus. So, what is meant by the nucleus? Every particle in the nucleus are said to be nucleons. So, every particle, each and every particle in the nucleus are said to be nucleons. Not an proton neutron pair are not said to be nucleons. So, you always remember it. So, proton neutron pair is not said to be nucleons. Every particle in the nucleus are said to be nucleons. So, from 8O16, 8 is the atomic number, 16 is the mass number. So, from that we know how many protons in the nucleus, how many neutrons in the nucleus, how many electrons in the atom. So, not in the nucleus, because proton and neutron are in the nucleus, but electrons in the atom. So, how many particles, total number of particles is also known as the total number of nucleons. So, nucleons is nothing but each and every particle in the nucleus are said to be nucleons. So, from that we know the 8 protons in the oxygen atom. So, 8 neutrons in the oxygen atom, but 8 electrons in the oxygen atom. From 8 oxygen 16, we have the 8 protons in the oxygen nucleus, 8 neutron in the oxygen nucleus, but 8 electron revolving in particular orbitals, K cell, L cell or cities you already know. So, but this lesson belongs to nucleus. So, we worry about the electrons. So, we consider only the 8 protons and 8 neutrons. If we want to calculate the total mass of the nucleus, just this is the mass of the one proton, you already know in terms of atomic mass unit. So, mass of the proton is equal to 1.00866 atomic mass unit. So, here we have the 8 protons. So, mass of the one proton into number of protons. So, we are getting the total mass of the protons in the oxygen nucleus. So, oxygen consists of 8 protons. If you want to know if you want to calculate the mass of the 8 protons, this is the mass of the one proton into 8. So, we get the total mass of the protons in oxygen nucleus. And similarly, we are having the 8 neutrons in the oxygen nucleus. So, this is the mass of the neutron in terms of atomic mass unit. I hope you already know 1.00727 atomic mass unit. So, 1.00727 atomic mass unit, this is the mass of the one neutron in terms of atomic mass unit into number of neutrons. So, suppose if you want to calculate the total mass of the nucleus of the oxygen atom, oxygen nucleus, so we already know oxygen nucleus consists of 8 protons and 8 neutrons, 8 protons and 8 neutrons. So totally if we want to calculate the total mass of the nucleus, we have to add these two values. So this is the mass of the value of one proton into number of protons, this is the mass of the neutron into number of neutrons. So if while we are adding, we are getting the total mass of the nucleus. So from this we can calculate the total mass of the nucleus is 16.12744 atomic mass unit from the calculation. So from the nucleons, so we are having the here oxygen consists of 16 nucleons, in among 16 8 protons are there, 8 neutrons is there. From this value, from this calculation value, we can calculate the total mass of the nucleus is 16.12744 atomic mass unit. But when we are using the atomic spectroscopy or some experimental observation, then actual form of the actual mass of the nucleus is 15.99053 atomic mass unit. So there is the mass difference. If you want to calculate the mass of the oxygen, we conclude we are having the 8 protons and 8 neutrons. By mathematically we can calculate the total mass of the nucleus. This is the total mass of the nucleus by calculation method. By using the spectroscopy, we can calculate the mass of the nucleus, the actual mass. Actually, total mass is nothing but the mass of the nucleus obtained from the calculation method. Actual mass is nothing but the mass of the nucleus obtained by the experimental method. So this is by the calculation method. Total mass of the nucleus is the calculation method. Actual mass is nothing but the mass of the nucleus obtained from the experimental method, which are in the same. But here the controversy is there is which are not same. Actually same irukano, but there is no same, which are not in the same equal value la kadiyadu. So there is the mass difference, which is also known as the mass defect. In the mass difference நம்ம mass defect அப்படினு நம்ம சொல்றோம். So the mass defect is nothing but that is the difference of mass between the calculation method and the experimental method, or in other words, there is the mass difference between the total mass of the nucleus calculated by the calculation method and the actual mass of the nucleus calculated by the experimental method. There is the mass difference, so which is till m is equal to 0.13691 atomic mass unit. So there is mass difference means somewhat mass will be disappear. So somewhat mass will be disappear, that is known as the mass defect. So the definition of mass defect is nothing but when protons and neutrons are combined to form a nucleus, when protons and neutrons are combined to form a nucleus, so there is the mass difference, Actually, in other words, when mass difference is nothing but the mass difference between the nucleons and the nucleus. So remind, mass difference between the nucleons. So this is the mass of the nucleons by calculation method. So this is the mass of the nucleons by calculation method. This is mass of the nucleus. So in the 16.1274 அப்படின்றது mass of the nucleons, not a mass of nucleus. And similarly, actual mass is mass of the nucleus only, not a mass of the nucleons. So del m is nothing but the mass difference between the nucleons and the nucleus. So how much mass we can lose means we can lose our the difference of mass is 0.13691 atomic mass unit. By numerical methods or simple expressions, or delta m, here delta m is equal to z mp plus a minus z into mn minus capital M. Here delta m is nothing but mass defect or mass difference. Delta m is nothing but mass defect or mass difference. Here z is nothing but atomic number. Here mp is the mass of the proton, plus here a is known as the mass number, here z is the atomic number. So mn is nothing but mass of the neutron, minus m is nothing but the mass of the nucleus. So z mp plus a minus z into mn is nothing but mass of the nucleons, minus m is nothing but mass of the nucleus. So here delta m is nothing but the mass defect. So z is the mass z is nothing but atomic number. So mp is the mass of the proton. Here a minus az number. If you want to know the number of neutrons in the nucleus, you have the formula a minus az. You already know, I hope. So here mn is the mass of the neutron. Here capital M is the actual mass of the nucleus. Here capital M is nothing but actual mass of the nucleus obtained from the experimental method. So by using the spectroscopy method, we can calculate the actual mass of the nucleus. Here Z into MP plus A minus Z Mn அப்படின்றது so total mass of the nucleons, total mass of the nucleons, total mass of the nucleons from the calculation method. So there is the mass difference between the calculation method and experimental method. So the mass difference is commonly known as the mass defect. Okay, so there is the mass difference, you already know. So mass defect is nothing but mass difference between the total mass of the nucleons to actual mass of the nucleus. Where the mass goes, the mass வந்து எங்க போயிருக்கும் அப்படினா the difference of mass, all the mass is converted into energy, which is commonly known as the binding energy. So in the converted mass is converted into energy by Einstein mass energy relation, E is equal to mc square. Here EB denotes as the binding energy, so binding energy is equal to delta m into c square. So first of all we know about the binding energy. What is meant by binding energy? So here what I told, actually what I convey the message means there is the mass difference, the mass is converted into energy by E is equal to mc square. So the energy is converted into binding energy. What is meant by binding energy? So binding energy is nothing but when proton and neutron combine to form a nucleus. So the number of protons and the number of neutrons combine to form a nucleus, the mass disappears, is converted into energy. That energy is known as the binding energy. So how much mass we can lose, all the mass converted into energy by Einstein mass energy relation, E is equal to mc square. Here EB denotes as the binding energy. So here EB denotes as the binding energy. So delta m is nothing but the mass defect. Here c square is the velocity of light. So this is the binding energy of the nucleus. If we want to know the binding energy of the nucleon, means we are having the three pairs in the nucleus, proton pair, proton neutron pair, or neutron pair. So in between the proton and proton pair there is the no repulsive force. Why? Because there is some other force which is greater than the repulsive force. So suppose that force or that energy is known as the binding energy. So binding energy is nothing but when protons and neutrons to form a nucleus, the mass disappears, is converted into equal amount of energy. That energy is known as the binding energy, which is denoted in the symbol of EB. Then EB is equal to mc square. Here instead of m we can write the delta m into c square. This is the binding energy of the nucleus. So here EBN, so EBN is nothing but binding energy per nucleon, I hope you already know. Nucleon is nothing but every particles in the nucleus are said to be nucleon. So if we want to calculate the binding energy of the nucleus, we have the formula delta m into c square. Suppose if we want to know the binding energy of the nucleon, so binding energy of the nucleus divided by mass number is nothing but how many particles we are having in the nucleus, or how many nucleons we are having in the nucleus. So from that we can calculate the binding energy of the nucleon or binding energy of the nucleus. So whatever we want, we have the formula binding energy of the nucleus or binding energy of the nucleon. Here we have the graph. So x-axis we have in the mass number. So mass number, so A. Here y-axis is nothing but the binding energy per nucleon. Y-axis is nothing but binding energy per nucleon. So from this graph, so in x-axis we are having the mass number, y-axis we are having the binding energy per nucleon. So mass number is nothing but, so from the mass number we can know how many particles in the nucleus or how many nucleons in the nucleus, or how many nucleons in the nucleus from the mass number we can know. In y-axis we are having the binding energy per nucleon. So y-axis we are having the binding energy for the nucleon. So the formula for binding energy per nucleon is nothing but EBN is equal to binding energy of the nucleus by mass number. So from this graph, for 1H2, 1H3, then alpha particle 2He4, then 3 lithium 6 and 2He4 nothing but not an alpha particle, it is an helium atom. So 3 lithium 6, then 6 carbon 12, 7 hydrogen 14, 8 O16 and 10 neon 20. So we are having the soft peaks. That means when mass number increases, binding energy per nucleon increases, decreases, for helium increases, lithium decreases, again for carbon 12 increases, again for nitrogen 14 decreases, again for oxygen 16 increases, again the neon 20 decreases. So there is some variation, increases or decreases. That means there is a change in value while we are raising the mass number. So while we are raising the mass number, the binding energy per nucleon are randomly changing. Randomly changing means sometime increases or sometime decreases. Then after that it is slowly increases but reaches the value for the 56. So for 56 it is the maximum value. So for 56 means it is nothing but ion. So ion having the maximum binding energy. Actually binding energy is nothing but binding energy is proportional to stability. So if one have higher binding energy, that means it will having the higher stability. So among the elements we are having the maximum binding energy for the ion 56. So this is the reason why ion is more stable. So this is main reason for ion is stable means binding energy is maximum for known elements. So binding energy maximum means stability is maximum. So binding energy is proportional to stability. So first of all, when mass number increases, binding energy per nucleon so randomly increases, randomly decreases, but then after neon 20 it is slowly increases, obtained for maximum for the ion 56, obtain maximum for the ion 56. So for known elements the maximum binding energy for the ion 56 it will having the value of 8.75 million electron volt binding energy per nucleon, binding energy per nucleon 8.75 electron volt for ion nucleus. If we want to calculate the binding energy of the nucleus, so here 8.75 million electron volt is nothing but binding energy of the nucleon. So binding energy of nucleon is nothing but the binding energy between the two pairs only. So two pairs only, proton proton or neutron neutrons or whatever it will be, or either one pair. Okay, so here binding energy per nucleon for ion 56 is 8.75 million electron volt. Suppose we want to calculate binding energy of the nucleus, we have the formula EBN is equal to EB by A. Here EBN is nothing but binding energy per nucleon, we already know 8.75 electron volt. So 8.75, here A is the mass number is nothing but total number of nucleons in the nucleus. Here EB is the binding energy of the nucleus. This is binding energy of the nucleon, here this is the binding energy of the nucleus. So from this formula we are going to calculate the binding energy of the nucleus. So by rearranging this formula, EB is equal to EBN into A, that means binding energy of the nucleus which is equal to binding energy of the nucleon into mass number. So binding energy of the nucleon is 8.75 million electron volt into the how many nucleons in the nucleus means 56. So 8.75 million electron volt is nothing but binding energy of the nucleon. So 56 is nothing but the number of nucleons in the ion nucleus. So 8.75 into 56 means we are getting the 493 million electron volt. So known elements, so those elements having the maximum binding energy means ion nucleus. So this is the reason why ion is more stable. So binding energy is nothing but stability. So those elements having the mass number less than 20 or mass number less than 170, the binding energy or the value of binding energy is low. So this is the reason. So those elements having the mass number less than 30 or mass number greater than 170 are unstable and radioactive. Radioactive is nothing but forthcoming class we can detailly study about the radioactive. So radioactive is nothing but one can automatically, without applying of any energy, one can automatically emitting alpha, beta, gamma radiation. In forthcoming classes we can detailly study about the radioactive. Then again, so the curve is slowly decreases. For uranium, so uranium we having uranium 238. 238 means mass number 238 means we are having the 238 particle in the uranium nucleus. So we are having the 238 nucleons in the nucleus. For uranium 238 the binding energy is 7.6 million electron volt. Here 8.75 million electron volt for ion nucleus, but uranium 7.6 million electron volt. So compared to the ion, uranium having the lesser binding energy. This is the reason why ion is stable, uranium is unstable. So because ion having the maximum binding energy then compared to the uranium, uranium is unstable. And radioactive, radioactive means it will automatically emitting the, when it observing uranium element, when it going to observing the neutron, automatically it will be exploded by emitting of alpha, beta, gamma radiation and some other krypton, xenon, barium and so on. So okay, suppose if you are taking the, or if you are going to take the higher element having the mass number of 240, it is able to break into the two elements. So A120 and A120. Suppose A140 is unstable. Why? Because it should be in the range of uranium. Here uranium for 238, here 240. But 120 is the stable one. So here A140 is called as the parent nucleus. So A120 and A120 is known as the daughter nucleus. That means from this equation what we learn means compared to the parent nucleus, daughter nucleus having the higher binding energy. That means compared to the parent nucleus, daughter nucleus having the higher stability. Why? Because of here 140. So those elements are in the range of 140, the binding energy is very less in order of 7.6. But those elements are in the range of 120. So the binding energy, so 120 means here 100. So 120 means in the range it should lie in the 8.5 million electron volt. So when mass number increases, initially mass number increases, binding energy per nucleon randomly increases, randomly decreases, then after some time slowly increases, then obtain maximum for the ion nucleus, then slowly decreases. For the slowly decreases, finally we can find the binding energy of the nucleus of uranium. So it's 7.6 million electron volt.